assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
So for writing formulas of the complex compounds or coordination compounds, we need to follow the rules mentioned here. So at first, we need to identify the cationic and anionic part, and we will have to write the cationic part first and then the anionic part. And then within the complex, we need to start with the central metal atom, and then we have to write the ligands. And if we have one ligand in multiple number, then we have to write down the number of ligands as subscript outside a round bracket and putting the ligand name within this bracket. And then we need to put a square bracket around the whole complex. And later you have to calculate the net charge on the complex, and if it is not a compound and if the complex has any charge, then you have to put the charge outside the square bracket as a superscript. And in case of compounds, the net charge will be 0, so you'll have to make sure that the net charge on your compound is 0. And for writing the name of a complex compound, we have to start with the with the with the prefix to indicate the number of ligands, like bi, like di, tri, tetra, or bis, tris, tetrakis for complex ligands. And then we have to write the name of the ligand. And if we have multiple type of ligands, then we'll have to arrange them in alphabetical order. And then finally we have to finish the name of the complex, writing the name of the central metal atom followed by its charge as a Roman numeral within a round bracket. And in case of compounds, we'll have to write the cationic part first and then the anionic part. And in case of an anionic complex, we have to add an 8 at the end of the name of a central metal atom. For example, for iron, it will be ferrate instead of iron, chromate instead of chromium, manganate instead of manganese, and so on. So now let's have a look at the problems here given here. So for part A, we are given a complex ion with 4 water molecules and 2 O and O ions connected to a iron 3 ion. So our central metal atom here is iron. For writing the formula, we have to start with the central metal atom, and then we have to put our 4 water molecule inside a round bracket, and we put the number of water molecule as superscript or subscript, and then we have to put the O and O, which is the nitrito group. We have 2 of them, and then we just put a square bracket outside it, and now we have to calculate the net charge. So water is a neutral molecule, it has 0 charge. Our ONO group has negative 2 charge, and our iron here is since it's a 3 iron, it has a plus 3 charge, so net charge is plus 1. So we have to put a plus as a superscript outside the square bracket. Now we have to name this formula. So for naming, we have to start with the ligands in alphabetical order. So for water, we use the name aqua, and this is our nitrito group. So in alphabetical order, our aqua will come first. We have 4 water, so we'll have tetra aqua, then we have 2 nitrito group, that means dinitrito, and then we have to put our central metal atom, which is iron, and iron has a 3 charge here, so we'll have to put 3 in Roman numeral in a round bracket. So this is our name for the formula here. Now for part B, we are given a coordination compound with made of 2 complex ion. In the one complex, we have vanadium 3 ion with 2 ethylene diamine molecules and 2 chloride ions as ligands. So we start with our central metal atom vanadium. Then we have our ethylene diamine, 2 of them. And then we have our chloride, 2 of them. And then we put square bracket outside it. Then we start writing our second part, or the anionic part, where um, we have one nickel, and it said that its coordination number is 4 and the ligand is chloride. That means that 4 chlorides are bound to the central metal atom nickel. So we have NiCl4 here. So this is our formula, but we have to make sure that the net charge is 0 here. So ethylene diamine. So first we have the vanadium, which is of +3 charge, and then the ethylene diamine, it's a neutral molecule, 0 charge, and for 2 chloride we have -2 charge. So overall here we have +1 charge, and here the nickel is +2, and the chloride has -4. So in total the charge here is -2. So we have +1 here, we have +1 -2. That means we need to multiply it by 2 to neutralize the charge. In that case, we have to put a 2 outside the square bracket of this cationic complex. So that is our formula for this complex. Now let's name it. So while naming it, we have to start with this cationic part, and for this we have to start with the ligand names. So one ligand is ethylene diamine and another one is chloride. So in alphabetical order, chloride will come first. We have 2 chloride. That means we'll have to write dichloro. Then we have 2 ethylene diamine. So since ethylene, in the name of ethylene diamine, we have on one di already. So in that case, we will not write it as diethylene diamine. Instead of using di, we will use bis, which is actually used for this kind of complexes. Write bis ethylene diamine. And then we have our vanadium as the central metal atom, which has a charge of 3. And then I'm writing the rest of the anionic part in the second row. So here in the anionic part we have 4 chlorides, so we write tetrachloro. And so as we said in the rules that for the central metal atom in an anionic complex we need to add 8 at the end. So our central metal atom name will be nickel 8. Nickel 8, and it has charge 2, so 2 at the end. So this name is not separated, we just this is one name altogether. First our cationic part and then anionic part.